Hello, everyone. Welcome to the fifth and final. Yes, hands raised up. If you don't know why, please look at the previous four design videos. Welcome to the fifth and final X/Twitter API design video. This is our engineering slash product slash TPM talks. Special welcome to engineering and product builders, doers who are about to land the ship now. Hope you have your seatbelts on. We like to start with a thought that may or may not be related to the discussion at hand. Today's thought of the day is from John Dryden, who says, "Beware the fury of a patient man. Beware the fury of a patient man." I'm not just saying that because to walk through all five videos may require patience, but of me creating it and of you watching it. But I guess that's how you would feel when your patience in going through my TPM talks brings you that furious reward in your dream job or helps you deliver a solution that you previously could only just think about. Now, let me know if you agree with John Dryden. Let me know if you'd like to see a different thought of the day. You can just put it in the comments below. And let me know if you believe this means something totally different and I've got it wrong. Who is this for? I've said that TPMs, system or engineering program managers, engineering leads, software engineers, product leads. We've covered all the ones struck out, and now we're making progress quickly towards design evaluation and latency. I like to say that if you're having an interview, let me know. I got your back. I'm always happy to do one-to-one sessions as well to prep you with different tech stacks that I haven't even made videos for yet. It's a tough job market right now. Early career opportunities are drying up. That's the financial standard saying that, not me. And US employers are cutting costs, but not just them. In UK, everywhere, it's the same old story. My hope is to help you navigate that. Okay, so let's go to the latency evaluation, right? The tweet API, as we said, stores a tweet and returns the created tweet attributes in response, right? So we assume our tweet API will allow us to post um, different types of content. So for instance, we expect it to allow us to post text, mentions, hashtags, images. In our design, we set up to 4 images, videos. In our design, we said just one video with a maximum size of 10 megabytes. Yeah, I know we're being stingy, right? Um, Now, for the images and videos, they will first require uploading the media files to the server, retrieving the media ID, and then the tweet is posted, which is why sometimes you see like some time lag between when you post a video compared to when you just post a tweet by itself. Something that's important to identify when you want to look at latency is the request and response side, request and response size. Now, since the post request will contain both media and tweets, we need to estimate the sizes separately. Okay, so for the media size, let's say that the time taken to upload the media file is 414 milliseconds, right? This is assuming, and I'll do the calculations in a bit. This is assuming the image file is 175 kilobytes. For a plausible service, now let's make sure our service is plausible, realistic. we will say that the maximum possible latency we can tolerate is half a second, right? So say 500 milliseconds. Okay. Then for tweet size, for posting the tweet, we have to consider the request header, and I'll show you the calculation in a bit, which will take 1 kilobyte, and the request body say slightly a little bit more, 1.12 kilobytes, right? Just because the request body will comprise other data entities. Remember, we showed the list of data entities that we consider, but for the request body, we expect to see things like the tweet ID, the user ID, content, media ID, etc., right? So for us to get the final request size, is going to be an addition of the headers, the metadata, all together. Okay? So the request and response body size, those are the things together that help us deliver that. So looking at it in terms of the what we just discussed, right? So there's going to be latency in between the client and the API gateway. Typically, it's important to know the minimum latency and the maximum. I'll show you how we've calculated these numbers. Then between the API gateway and the backend, you have to consider the processing time. Now, altogether, we're saying that the maximum user perceived response time will be slightly over a second, 1029 milliseconds. And excluding upload time, it will be 469 because you have to calculate the processing time versus the maximum latency time. Okay, this is for the Tweet API. And I said I was going to do the calculation. So here we go. So here we have assumed the request size. We have assumed the size for the response, say 4 kilobytes. Then to find the latency, you need to add the base time plus the round trip time. RTT is round trip time for post, and the time for download. Okay. The round trip time for post, again, is the base round trip time plus an industry known weight times the request size. So in other words, yes, the size of the request does have an impact, but it's nuanced. The time for the download, again, is based on industry factorial of 0.4 times the response size. The time for the latency, when you add them all together, you get 384.538 milliseconds. The time for latency max, so you want to find what's the minimum latency and the maximum latency. Again, using this, plugging in the numbers, it's 465.53. Now, let me know if you agree with these numbers below. Let me know if you're going to calculate it differently. Now, for the response time, right, it's almost a similar kind of calculation. The minimum response time depends on the latency minimum and the time it takes to process. So it's 4 milliseconds. You add them together. The maximum will be the maximum latency we've allowed and the maximum processing time, which gives you that number. We say the user perceived latency or the user perceived response time, which is 1/2 of latency for 3 images with text, will be over 1 second based on the calculation below. Let me know what you think. This is for the Tweet API. Let me know if you approach this differently. Let me know if you agree with the calculations. Again, for the Timeline API, which is more complicated, let me get face out of the way. Seems your face is here to stay this time. Okay, let me do it. Yeah, so for the Timeline API, right, we've said while the Tweet API only returns the most recently posted tweet in response, the Timeline API returns a lot more. It returns the stream of tweets with ads, people, and thread. Again, it's essentially the same process. We have to calculate the request and response time. Now, someone may say, hey, we say the timeline API returns more tweets. So why is the maximum response time lower? That's because the size of the get request, that's the HTTP get verb, is typically smaller than the response because the response body is empty. So that's a bit counterintuitive. If this doesn't make sense, send me a DM. I'm happy to walk through this with you, right? However, because the get response is empty, we only consider the response time to estimate the request response time. It's almost like only calculating half of what we did for the tweet API. Okay. So let's move to the timeline service response time. The image will show itself. Perfect. So the timeline API response body, 100 tweets for 10 trends, 5 promoted ads. Again, this is just an assumption. Okay, just for an assumption. Beneath the hood, we can calculate the latency as the minimum latency time will be the base plus the round trip time times 0.4 times the size of the response. That gives us 258 milliseconds. And then the maximum latency is the maximum base times the round trip time for get and 0.4 times the response size. Plugging in those numbers again for the response time, we see the response max to be 408.5 milliseconds and the response min to be 262.5 milliseconds. And this is how it looks like in terms of the maximum latency from client to API gateway and the maximum processing time. Also note that the maximum processing time, even though the overall response time is lower, 408 versus 1 millisecond for the tweet API, but the processing time here is higher, 69 milliseconds versus 4 milliseconds, because it's doing more because of those timeline generation service, the trend service, people discovery service, ad service. So those add more detail. Okay. So what did we cover? To recap, parts 1 to 4, we've covered functional requirements and non-functional requirements, supporting services, design decisions, and API model. And this session, which is the last session, by the way, don't tell me you're happy to hear that. I'm not. Is a design evaluation and the latency. So just to recap, we have looked in details at the API design for X, formerly known as Twitter. We've looked at possible requirements to support the services, etc. I've asked quite a ton of questions and hopefully answered tons of yours. If you have any question as to what you see here, if you would like me to look at a specific tech platform, if you'd like me to make a specific video, or you even have any questions, clarifications, or you're preparing for an interview, let me know, DM me, inbox. Don't forget to like or subscribe. My intention is to be getting these videos out once or twice a week, if not more. Okay. Thank you very much, everyone. Bye. Don't forget